NCERT Physics Class 11th, 7th chapter, System of Particles and Rotational Motion, question number 7.22. In this, we have given that two sides AB and BA, each of 1.6 meter long, and hinged at point A. Rope D is of 0.5 meter length, weight of 40 kg suspended from it. F is point, which is distance of 1.2 meter from B. So this total length from A to B is 1.6, and from B to F is 1.2. So we can say that this length is 0.4 meter, and this length is same as this length is 0. From A to F, the length is 0.4 meter, and from F to D, the length will also be 0.4 meter. Length of D is given as 0.5 meter, and the length of from B to C will be 1 meter. Let's say this angle is theta. Now, first of all, we are going to make the free body diagram of the given system. The normal force which is acting in this is there is NC. Normal force at B can be written as NB. W, that is acting in vertical downward direction. If the system is in equilibrium, so first we are using the condition of translational equilibrium. For translational equilibrium, we can say that summation of forces in y direction should be 0. The forces which are acting in y direction are NB, NC, and W. So net force in y direction should be 0. So we can say that NB plus NC is equal to W. So this is our first equation of motion. So now moving to second part, we are going to use the condition of rotational equilibrium. So torque about A is equal to 0. In case of rotational equilibrium, torque about any of the point can be 0. So with this, we are taking the torque about A, which is equal to 0. So in case of torque about A, the torque of NB and NC and W are supposed to be come. So the torque of NB can be written as torque due to force NB can be written as NB into perpendicular distance of this normal force NB from point A, that is equal to 0.5. Now we are taking this, the torque of NB about point A is in clockwise sense, and we are taking the clockwise sense as positive. So this is positive. Now torque of NC about point A is negative, and we are taking as is in anti-clockwise sense. So we are taking as negative. And torque of W about point F about point A is also in anti-clockwise direction. So it would also be in negative sense. So now perpendicular distance of this force W from point A can be seen from this point. So by using the concept of similar triangle, this is a smaller one and this is larger one, we can find the value of this small distance. And this small distance comes out to be 0.5 divided by 4. And this torque about A equal to 0. On solving this, we have NB minus NC is equal to W by 4. This is our second equation. Now from the equation first and second, we can say by adding first equation with second equation, this implies that the value of 2NB comes out to be 5 omega by 4. 5W by 4, where W is the weight. And on solving this, the value of NB comes out to be 5 by 4 into 2 into W, where W is equal to mass into G. The value of G is 9.8. This can be written as 245 Newton. So this is the value of answer of NB. Now in order to find the value of NC, we can say that NC can be written as W minus NB, and W is equal to 4M into G, that is 40 into 9.8 minus NB, which is equal to 245. So on solving this, the value of NC normal at C comes out to be 147 Newton. Now moving further, we are going to support the second part. We are going to solve the second part, which is find the tension in the rope. Let's say the tension in the rope is T and T. So we are considering the ladder AC for ladder AC, and again torque about point A is equal to 0, as the whole entire system is in equilibrium. So ladder AC would also be in equilibrium, and we are considering the torque about point A. So the torque about point A is due to the tension and NC. So we are considering the ladder AC and taking the torque about A, so we can say that torque about A can be written as NC into perpendicular distance of NC from A is 0.5 minus of T into perpendicular distance of this tension from point A can be written as this angle is theta. So we can find the value of cos theta as, from diagram we can find the value of cos theta as cos theta is equal to 0.5 upon 1.6, and on solving this the value of theta comes out to be 72.8 degree. Once you get the value of theta, you can get the value of sine theta, and the perpendicular distance of the tension from the point A is given as 0.8 sine theta, and this must be equal to 0. Now the value of NC, that is equal to 147, on substituting the value of NC, that is equal to 147 into 0.5 is equal to T into 0.8 into sine theta. The value of T can be achieved as the value of T comes out to be in this situation of 147 into 0.5 divided by 0.8 into sine theta, and the value of sine theta is sine of 72.8. On solving this expression, the value of tension comes out to be, the value of T comes out to be 96.17 Newton.